Hi, this is Bill Geyer with Archer Pilot, and I'd like to show you how to analyze the log for a feed-forward tune type test. So I have a user's log here who conducted a flight to tune both feed-forward and the rate P and rate D gains, but we'll just look at the feed-forward part of it. And first, we talked about the different messages in the log file that deal with the auto-tune tuning. And these are the ATDH, which is the details, the ATNH, which has kind of some summary data, and then the ATSH, which is sweep information, frequency sweep information. So for the feed-forward test, you'll just want to start with the ATDH. So you can expand that, and I'm working in Mission Planner here, so you can use whatever log viewer you'd like. And for this ATDH, you'll go ahead and do the target rate and rate, and click on those to plot them. And so you can see that this user had done some feed-forward tuning, as well as, again, this rate D and rate P tuning, which is all these squiggly lines over here. That's the frequency sweeps and dwells. So, but this over here is what your feed forward tuning looks like. And so we can expand that or zoom in on that here. And so a couple of things about feed forward tuning and what to look at if you think it's not working, right? So maybe it's been doing it for quite some time, maybe 2 minutes trying to tune, gone through a number of iterations of it, tilting forward and backwards, or depending on what axis you're tuning. In any case, here's some things that could be happening. So first of all, just be aware that if you switch out of auto tune like this user did, and then back into auto tune, it'll actually restart the process for tuning feed forward. And what I mean by that is it'll actually, if you see this first event here, what happens is you can see that they're not well matched between the target rate and the actual rate. So the actual rate's in green. And so it's actually doing the calculation initially. It does this maneuver, and it tilts the aircraft in one direction, and then gets some rate in the opposite direction. And it achieves, tries to get it to achieve 50 degrees per second, but then it sees what it can achieve, which in this case, if I look at the point values, is only 31 degrees, 32 degrees per second. So then it just does a calculation to determine what is the feed forward gain, and then it'll iterate to kind of refine that initial guess, or calculation, I should say. So what happens is if you restart auto-tune, it'll then have to do that all over again and start doing the process. However, if you were just to move your sticks, right, you move your controls and just take over control of the aircraft to kind of bring it, reposition it, it'll stop the auto-tune, and then it'll pick up where it left off. So along with that is kind of not touching the sticks until it completes its maneuver. And I know it's tough to determine, but you kind of can count like maybe 5 seconds from when it starts, and then that should be the end of it, and try to catch it before it starts the next one if you're going to reposition. That way it gets through a whole cycle, and it doesn't really record the information and say it's complete until it gets through the full iteration of that data. And so over here, you can see it was interrupted once or twice here, and let's zoom in on this. And so when it's interrupted, so at this point, it's kind of coming back, and it's going to stop the roll rate in one direction, or pitch rate, and then recover the aircraft. And you see the straight line here is telling me that they took over before it was able to get back to the level position. And so what that does is it causes it to have to start over again. So that's the other thing you have to watch for. Don't pull the aircraft out of the maneuver or take over control until you think it's complete. So again, just try not to disturb it. Give it 2 or 3 times to get started before you take over and pull it back to position. Now, again, that doesn't mean if it's getting far away from you, please take control of the aircraft and bring it back closer to you so you don't lose sight of it, or you can't recover the aircraft on your own if it gets too far away. All right, so that's kind of some things to look for in the data to make sure that you get good data. So in this case, let's just walk through kind of what happened with these results once he kind of let the aircraft go and do its thing. So you can see here it did its initial maneuver, and that caused it to calculate this feed forward gain. And then you can see it did a much better job here. You can see it nearly matched the rate of this of the response, or the actual nearly matches the desired. And so it must not have been good enough, because what it does is uses the rates at the end to calculate how close it is, and it tries to get them within 5% of each other. So in this case, it changed the gain a little bit and redid the maneuver to then do the second one here. And at this point, it considered that close enough, within 5%, and then it does it in the opposite direction. So in this case, it rolled, I think it's the roll axis, it rolled to the left and then rolled to the right to get some steady state rate, and then recovers by rolling back to wings level. And so here it felt rolling to the right, it got a good response, and now it starts doing it in the opposite direction. And so this one starts going in the opposite direction. So you notice here that there's something going on here that we don't quite understand. You can see that the rate kind of falls off. The actual rate kind of falls off towards the end there. And so that's causing poor results. And it does it quite a number of times until then it finally determines a value where it actually matches to its satisfaction to within 5%. And so that's when it says it was complete, and stopped the tuning process for the feed forward here. And what it does is it'll take the one it calculated for rolling to the left and one it calculated for rolling to the right. It averages those and then uses that value for the final value. Well, actually, it's about 90% of that value for the final value. You can see kind of the iteration if you go and you look at the AT&H, and I kind of look at this in the table format here. So I'll just use, basically I just left clicked on this header area here, and then it allows me to choose the message I want it to list in the table. And so then I can choose the AT&H, hit filter, and it just filters out the AT&H values. So if you look across the top here, we have a bunch of different things, frequency, gain, phase. You can see these are all 0 because it doesn't use those for the feed forward tuning. It uses basically just the RFF, or the rate feed forward, is what it's tuning here. And the tune type, and this is a little bit arduous, but basically it is 4 for the feed forward tuning. And so wherever you see 4 here for tune type, that's a feed forward event. And so it started off with 0.15. Its initial guess was 0.255 from that. And then it went on to then refine that. I think it refined it to like 0.26 before it went to the opposite side and did it in the opposite direction. So the rest of these are basically trying to tune and get the opposite direction correct. And then finally, when it switches over to tune type 8, which is starting the rate D and rate P tuning, it came up with its value of about 0.26 for the feed forward gain, which was the average of these two and 90% of that. So that's the feed forward analysis of the log for the feed forward tuning type. One last parting thought here is that if you're having troubles and you're seeing that it's not doing well in doing this tuning, you can always do a manual calculation. One other thing to look out for is that if it gets too high, you'll see that instead of the rate coming up nice like this and kind of approaching the target rate, you'll see that it'll become up a little bit more abruptly and maybe too sharply. And that's when we're going to tell it, when you start seeing that, that kind of tells you that it's getting too high. And so you may want to just try to calculate it on your own. And you can do like it does in the first case where it does the initial calculation. In fact, you may want to take the initial calculation if you think it looks good. And in that case, what you do is you plot the command signal. And this basically is just what the motors class is saying is the command required. And you can take the command value, which is 0.14, 0.15, right, and divide it by the actual rate in radians per second, right? Here it's 32.2 degrees per second. You do that in radians per second and divide that into the 0.146, and that will give you your feed forward gain that would be calculated. All right, well, that's all I have for this little segment. And if you have, you want to tune in to hear me talk about looking at your rate D and rate P tuning, you can look at that video next. Thanks for tuning in.